Imagine you're standing on a beach. You look out at the horizon, watching the waves crash against the shore, and it feels like the ocean is the biggest thing on our planet. It covers 70% of the surface after all. But what if I told you that everything you see, all that blue vastness, is just a drop in the bucket compared to what's hiding right under your feet? Scientists have recently discovered something that sounds like it was ripped straight out of a Jules Verne novel. Deep within the Earth's mantle, about 400 miles down, there is a massive reservoir of water that is 3 times the volume of all our surface oceans combined. This isn't a liquid ocean with fish and coral reefs, but a hidden world of water trapped inside a glowing blue rock. And it might just rewrite everything we thought we knew about how our planet was formed and where our water actually comes from. For decades, the leading theory was that Earth's water was delivered by icy comets and asteroids striking the planet billions of years ago during its violent infancy. It made sense at the time. The early Earth was a molten ball of fire, so any water it had initially should have evaporated into space, right? But this new discovery suggests a much more domestic origin story. It suggests that the water has been here all along, locked inside the very fabric of the Earth itself. We are literally walking on top of a subterranean ocean so vast it defies imagination. To understand how we found it, and what it means for the future of our planet, we have to travel deeper than any human, or even any drill, has ever gone. We have to look at the transition zone. The Earth is layered like an onion. You have the crust, which is the thin shell we live on. Then you have the mantle, and finally the core. Most of our geological action happens in the mantle, but it's incredibly hard to study because of the extreme pressure and heat. However, at a depth of about 400 to 600 kilometers, there's a region called the transition zone. For a long time, geologists suspected something strange was happening here. They noticed that seismic waves, the vibrations caused by earthquakes that ripple through the planet, were slowing down or changing behavior when they hit this specific layer. It was as if the rock wasn't as solid or as dry as it should be. The hero of this story is a mineral called ringwoodite. Now don't let the name bore you, because this rock is essentially a sponge for the Earth's interior. Ringwoodite is a high-pressure version of magnesium silicate. Under the crushing weight of the mantle, its crystal structure changes, allowing it to trap hydrogen and oxygen atoms. It doesn't hold water like a glass holds liquid. Instead, it traps the ingredients of water within its molecular structure. Think of it like a damp sponge. Even if you can't see the liquid water, the moisture is integrated into the material. This was purely theoretical for a long time until Stephen Jacobson from Northwestern University and his team started looking for proof. Getting a sample from 400 miles deep is impossible. The deepest hole humans have ever drilled, the Kola super deep borehole in Russia, only went about 7 miles down before the heat became too much for the equipment to handle. So, how do you see something you can't touch? You use the Earth as a giant ultrasound machine. Jacobson's team used a massive network of over 2,000 seismometers across the United States to listen to the Earth's heartbeat. When an earthquake happens, it sends waves through the interior. These waves travel at different speeds depending on the material they pass through. By analyzing the speed of these waves, the researchers could map out the composition of the mantle. What they found was groundbreaking. They detected that the seismic waves slowed down significantly in the transition zone beneath North America. This indicated that the rocks there were saturated with water. If the ringwoodite in this transition zone contains just 1% water by weight, it would mean there is 3 times more water deep underground than there is in all of the oceans on the surface. This discovery has massive implications. If the water has been there for billions of years, it means the Earth's water cycle is way more complex than we were taught in school. It's not just about evaporation, clouds, and rain. It's a deep Earth cycle where water moves from the surface down into the mantle through subduction zones, and then perhaps back up through volcanic activity or other geological processes. This hidden ocean acts as a sort of buffer. It's a reservoir that helps keep the level of the surface ocean stable. If all this water were on the surface instead of trapped in the mantle, the only land left visible on Earth might be the peaks of the highest mountains. We would be a water world, similar to some of the moons of Jupiter or Saturn. The fact that this water is locked away in the rock is the only reason we have dry land to live on. It's a delicate balance that has persisted for eons, allowing life to flourish. But why does this matter to you and me today? Well, understanding where our water comes from helps us understand the history of our solar system. If Earth's water came from within, it means that other rocky planets might have started with their own internal oceans too. It changes how we look at Mars or Venus. Maybe they had internal oceans that they lost, or maybe they're still there, hidden beneath the surface. It also helps us track how the Earth's interior stays hot. Water lowers the melting point of rock, making it more fluid. This fluidity is what allows tectonic plates to move. Without this lubrication from the hidden ocean, plate tectonics might grind to a halt. We wouldn't have mountains forming. We wouldn't have a planetary magnetic field to protect us from solar radiation, and the Earth might have become a geologically inactive rock billions of years ago. The discovery of this water-rich ringwoodite wasn't just based on seismic data, though. Nature actually provided a physical sample if you knew where to look. Occasionally, deep-seated volcanic eruptions bring material from the mantle to the surface very quickly. In 2014, a team of researchers found a tiny diamond in Brazil that had been puked up by a volcano. Inside that diamond was a microscopic inclusion of ringwoodite. When they analyzed it, they found that it contained about 1.5% water. This was the smoking gun evidence. It proved that the mineral which can hold water actually exists in the mantle, and that it is indeed holding onto that water. Think about the scale of this for a moment. We spend so much time looking up at the stars, searching for water on other planets, trying to find a second Earth. Yet, we are only just now realizing that our own planet has a hidden, massive component that we never fully understood. It's like discovering a secret basement in a house you've lived in your entire life. This reservoir isn't just a fun fact. It's a fundamental part of the Earth's machinery. Now, you might be wondering, if there's that much water down there, is it possible to get to it? The short answer is no, not with current technology, and probably not for a very long time. The pressures are so intense that any vessel we sent down would be crushed instantly. And even if we could get there, the water isn't in a form we could easily pump out. It's bound to the mineral at a molecular level. But that doesn't mean it isn't affecting us. This water plays a crucial role in the movement of magma and the creation of volcanoes. When subducting tectonic plates carry water down into the mantle, that water lowers the melting point of the surrounding rock, leading to the creation of magma that eventually erupts as lava. So every time you see a volcano, you're seeing the results of this deep Earth water cycle in action. This discovery also challenges the late veneer theory. This was the idea that Earth formed dry and stayed dry until it was bombarded by water-rich objects from the outer solar system. While it's still likely that some of our water came from space, the existence of this massive internal ocean suggests that a lot of it was here from day one. Earth might have been born wet. This shifts the focus for astrobiologists. Instead of just looking for planets in the Goldilocks zone where liquid water can exist on the surface, they might need to look for planets that have the right internal conditions to store water deep inside. The research is still ongoing. Scientists are now trying to determine if this water-saturated layer exists everywhere around the globe, or if it's just in specific areas like beneath North America. If it's global, the amount of water is even more staggering. They are also looking into how this water moves over millions of years. Is the hidden ocean growing or shrinking? How does it interact with the core? These are questions that will keep geologists busy for decades. It's also interesting to consider the cultural impact of such a find. For centuries, folklore and legends have spoken of vast underground worlds and hidden seas. While we haven't found a hollow Earth filled with dinosaurs, finding a massive ocean of water rock is almost as strange. It highlights how little we actually know about the world beneath our feet. We have better maps of the surface of Mars and the Moon than we do of the Earth's interior. We are living on a thin crust, floating over a complex and mysterious engine that we are only just beginning to decipher. What makes this discovery so fascinating is the way it links the very small with the very large. We are talking about microscopic changes in the crystal structure of a mineral like ringwoodite, happening at such a massive scale that it dictates the geography of the entire planet. It's a reminder that everything on Earth is connected. The clouds in the sky, the water in the glass you're holding, and the glowing blue rock 400 miles below the ground are all part of one giant, continuous system. As we continue to develop better seismic sensors and more advanced computer models, we will likely find even more surprises. Some scientists are already looking deeper into the lower mantle to see if water can be stored even closer to the core. If the transition zone can hold 3 oceans worth of water, what could the rest of the mantle hold? The potential for discovery is enormous. We are entering a new era of inner space exploration, where the frontier isn't light years away but right under our boots. The story of the hidden ocean is a testament to human curiosity and the power of science. We took the vibrations of earthquakes and the contents of a tiny diamond to reconstruct a world we can never visit. It shows that even in an age where it feels like everything has been discovered, there are still massive, world-changing secrets waiting to be uncovered. It makes you realize that the Earth is much more than just a ball of rock. It's a dynamic, living system with depths and complexities that we are only starting to appreciate. Imagine the perspective shift for a young scientist starting out today. A generation ago, the mantle was thought of as a fairly dry, solid place. Today, it's seen as a vast reservoir, a key player in the water cycle, and a driver of plate tectonics. This shift is what science is all about, being willing to change our minds when the evidence points somewhere new. And the evidence for this subterranean ocean is becoming harder to ignore every year. When we think about the future, discoveries like this are vital. As we face challenges like climate change and resource scarcity on the surface, understanding the fundamental systems of our planet becomes even more important. While we can't drink the water in the mantle, knowing how it affects the surface helps us model the Earth's long-term future. It helps us understand the stability of our environment and the processes that keep our planet habitable. The next time you look at a map of the world, try to visualize that extra layer. Don't just see the continents and the blue oceans. Picture the crust as a thin skin, and below it, imagine that massive, heavy layer of ringwoodite, holding on to its secret cargo. This deep Earth ocean has been there since the beginning, quietly influencing the world above. It's a silent guardian of our planet's water supply and a reminder that there is always more to the story than meets the eye. While the ocean isn't a place you could swim in, the sheer volume of water trapped there is a game changer. It represents a paradigm shift in geology. The transition zone, once thought of as just a boring middle layer, is now one of the most exciting places in the study of Earth's history. It's where the secrets of our planet's birth and evolution are tucked away. And the best part? We've only just started scratching the surface. As we wrap our heads around this, one can't help but feel a sense of awe. The Earth is a masterpiece of natural engineering. Every piece, from the atmosphere to the core, plays a role in sustaining life. Finding this hidden ocean is like finding a new chapter in the user manual for our planet. It tells us that the Earth is even more resilient and resourceful than we thought. It has its own way of storing and recycling the essentials of life, ensuring that even if things on the surface get chaotic, the seeds of the planet's water remain safe and sound deep inside. The hunt for more evidence continues. Scientists are looking at other minerals like wadsleyite, which also exists in high-pressure environments and can hold water. They are expanding our seismic networks to get a higher resolution picture of the mantle. They are even using supercomputers to simulate the conditions of the deep Earth with more accuracy than ever before. Each new piece of data reinforces the idea that we are a water planet through and through, from the surface all the way to the core. So, the next time someone tells you that the Earth is just a big rock, you can tell them about the glowing blue mineral and the 3 oceans hidden beneath our feet. Tell them how the vibrations of distant earthquakes revealed a secret world that keeps our continents afloat and our planet alive. It's a story of discovery that starts with a tiny diamond and ends with a whole new understanding of the world we call home. The Earth still has secrets, and we are just beginning to find them. This discovery also brings up an interesting question about the history of our planet. If the Earth was born wet, does that mean life could have started earlier than we thought? Or perhaps, could life exist even deeper than we've imagined? While it's extremely unlikely that anything could live in the transition zone due to the heat and pressure, the idea of internal water makes the possibility of subsurface life on other planets much more plausible. If a planet like Mars has a similar hidden ocean, could it have supported life deep underground, even after its surface became a frozen desert? This is the kind of thinking that this discovery triggers in the scientific community. It opens up new avenues for exploration and new theories about the habitability of the universe. The beauty of this discovery lies in its simplicity. It's a story about water, the most basic necessity for life, found in the most unexpected place. It's a reminder that we should never stop asking questions or looking at the world in new ways. Even something as solid and permanent as the ground under our feet can hold surprises that change our entire worldview. The hidden ocean beneath the Earth's surface is a magnificent reminder of the mysteries and wonders that are still out there, just waiting for us to find them. Scientists are also considering the role of this water in the magnetic field of our planet. The movement of the molten outer core is what generates our magnetic field, which protects us from cosmic rays and solar wind. If the mantle above the core is saturated with water, it could influence the cooling of the core and, by extension, the strength and stability of the magnetic field. This means that the hidden ocean might be indirectly responsible for protecting life on the surface from the harsh environment of space. It's another example of how the deep interior and the outer surface are inextricably linked. As researchers continue to analyze the data from the North American Seismic Project and other similar projects around the world, the picture will become clearer. We might find that some parts of the mantle are drier than others, which could explain why some areas are more geologically active. We might find deeper reservoirs or different minerals that store water in even more extreme conditions. The journey into the Earth's interior is just beginning, and every step reveals more of the planet's incredible complexity. In the end, the discovery of a massive ocean hidden beneath the Earth's surface is more than just a scientific milestone. It's a humbling reminder of our place in the universe. We are small inhabitants on a vast, mysterious, and incredibly well-designed planet. The more we learn about it, the more we realize how much we have to be grateful for. The Earth provides us with everything we need, often in ways we don't even realize. So here's to the hidden ocean, the blue rock, and the scientists who are uncovering the secrets of our incredible home. The world is a much more interesting place than we ever imagined, and the best part is, there's always more to discover. What's really fascinating is how this discovery changes the way we think about the water cycle. Traditionally, we think of the water cycle as the movement of water between the oceans, atmosphere, and land. But now, we have to include the mantle in that cycle. This is a deep water cycle that operates on a time scale of millions of years. Water is pulled down into the mantle at subduction zones, where one tectonic plate slides under another. Then, it's stored in minerals like ringwoodite for millions of years before being released back to the surface through volcanic eruptions. This means that the water you drink today might have spent the last 100 million years locked inside a rock 400 miles underground. It's a mind-blowing thought that connects our daily lives to the deepest parts of the planet's history. This deep water cycle also acts as a regulator for the Earth's climate over geological time. By storing such a massive amount of water in the mantle, the Earth can maintain a relatively consistent amount of water on its surface, which is crucial for the long-term stability of the climate. If too much water were to stay on the surface, or if too much were to be trapped in the mantle, the Earth's environment could change drastically. This balance is one of the many fine-tuned aspects of our planet that make it so perfectly suited for life. As we look to the future, the study of the Earth's interior will only become more important. With the help of new technologies like AI and machine learning, scientists can process vast amounts of seismic data more quickly and accurately than ever before. This will allow us to create high-resolution 3D maps of the mantle, showing the distribution of water and other minerals in incredible detail. We might even find other hidden reservoirs of different materials, like carbon or nitrogen, which are also essential for life. The discovery of the hidden ocean is a perfect example of how science works. It started with a hypothesis based on laboratory experiments, followed by indirect evidence from seismic waves, and finally, a physical sample found in a diamond. Each step built on the last, eventually leading to a discovery that changed our understanding of the world. It's a process of constant questioning, testing, and refining, and it's the most powerful tool we have for understanding the universe. For those who are passionate about science and discovery, this is an incredibly exciting time. We are living in a golden age of Earth science, where new discoveries are being made every day that challenge our old assumptions and open up new possibilities. The hidden ocean is just the beginning. There are still so many questions left to answer, so many mysteries left to solve. What else is hiding deep beneath our feet? How does the Earth's interior interact with the core? What can we learn about other planets by studying our own? The journey to understand our planet is far from over. In many ways, we are still like the early explorers who set out to map the oceans and continents. But instead of ships and compasses, we have seismometers and supercomputers. And the frontier we are exploring is not across the sea, but deep within the Earth itself. It's a journey that will take us to the very heart of our planet. And along the way, we will discover things that we never even dreamed were possible. Think about the scale of the transition zone. A layer hundreds of kilometers thick, wrapping around the entire globe. If the three oceans estimate is correct, we are talking about a volume of water that is almost impossible to grasp. It's a testament to the sheer size and complexity of our world. We often think of ourselves as the dominant force on Earth, but when you consider the massive geological processes happening deep beneath us, it's a very grounding experience. We are just a tiny part of a much larger, much more powerful system. This discovery also highlights the importance of protecting our planet. The Earth has its own built-in systems for maintaining balance, But those systems are delicate. By understanding how the Earth's interior works, we can better appreciate the fragility of the environment on the surface. We can see how everything is connected, and how even small changes can have big consequences. It's a reminder that we need to be good stewards of our planet, for the sake of ourselves and for future generations. The story of the hidden ocean is a story of wonder, discovery, and our deep connection to the Earth. It's a story that reminds us to keep looking, keep questioning, and never stop being amazed by the world around us. There is so much more to see, if we only know where to look. And who knows, the next big discovery might be right under your feet. As we move forward, it's important to keep supporting the scientists and researchers who are doing this incredible work. Their curiosity and dedication are what lead to these amazing breakthroughs. By studying the deep Earth, they are helping us understand our past, our present, and our future. They are showing us that the world is a much more complex and beautiful place than we ever realized. So, let's keep our eyes open and our minds curious. The Earth still has many secrets to share, and each one brings us a step closer to understanding the true nature of our home. Whether it's a hidden ocean, a new mineral, or a mystery we haven't even imagined yet, the journey of discovery is always worth it. And as we continue to explore the depths of our planet, we can be certain that there will always be something new and amazing to find. The revelation of this deep water reservoir doesn't just impact geology, it ripples through biology and the search for extraterrestrial life. If Earth can hide 3 oceans in its mantle, it stands to reason that other planets could do the same. This expands the habitable zone significantly. We used to think a planet had to be at just the right distance from its star to have liquid water on its surface. But if water can be stored internally, then planets that are too cold or too hot might still be able to harbor the ingredients of life deep underground, protected from the harsh conditions of space. This discovery makes the universe feel a lot more alive and full of possibilities. Moreover, the mechanism of water storage in minerals like ringwoodite is a fascinating example of high-pressure chemistry. In the extreme conditions of the mantle, the rules of chemistry change. Elements that would never bond on the surface can be forced together under immense pressure. Understanding these processes can lead to new materials and technologies here on the surface. For example, by studying how minerals trap and release water at a molecular level, we might find new ways to store energy or filter water. The lessons we learn from the deep Earth have practical applications that can improve our lives in ways we haven't even thought of yet. It's also worth reflecting on the history of this discovery. It wasn't one eureka moment that led to the realization of the hidden ocean. It was decades of incremental progress, from the first theoretical models in the 1960s to the seismic surveys of the 2000s, and finally the diamond inclusion in 2014. It shows that persistence is just as important as brilliance in science. It's about sticking with a problem, looking at it from different angles, and waiting for the technology to catch up with the ideas. It's an inspiring example of what human beings can achieve when they work together toward a common goal. As we think about the hidden ocean, let's also consider the role of water itself. It's a simple molecule, 2 hydrogens and 1 oxygen, but it's the most important substance on our planet. It's what makes life possible, it's what shapes our landscapes, and now we know it's what makes up a huge part of our planet's interior. Water is the thread that ties everything together. Finding such a massive amount of it in such an unexpected place only deepens our appreciation for this amazing substance. The discovery of the hidden ocean is a reminder that we should never take our planet for granted. The Earth is a complex, dynamic, and incredibly resilient system that has been evolving for billions of years. It has survived asteroid impacts, ice ages, and massive volcanic eruptions, and through it all, it has maintained the delicate balance that allows life to thrive. Finding this internal ocean is like finding a piece of the puzzle that we didn't even know was missing. It makes the picture of our planet a whole lot clearer, and a whole lot more fascinating. As we look up at the night sky, we can also look down at the ground beneath us with a new sense of wonder. We are living on a planet that is literally bursting with water, both on the surface and deep inside. We are part of a grand, ancient, and ongoing story, and there are still plenty of chapters left to be written. The hidden ocean is just one of the many secrets that the Earth is waiting to share with us. So let's keep exploring, keep learning, and keep being amazed by the incredible world we call home. What's also quite poetic is the idea of the glowing blue rock. Ringwoodite, despite being hundreds of miles deep, carries a name that sounds like something from a fantasy novel. Under the extreme heat and pressure of the mantle, it doesn't just hold water, It essentially acts as the Earth's inner container for the lifeblood of the planet. While it's not a liquid ocean you could sail on, the bluish color of the mineral itself reflects the very essence of our blue planet. It's as if the Earth is blue all the way through, not just on the surface. This underground ocean also influences how we understand tectonic activity. The presence of water in the transition zone makes the mantle more ductile, or plastic, which allows for the steady movement of tectonic plates. Without this lubrication, the crust would likely be much more rigid, and we wouldn't have the same level of volcanic activity that recycles nutrients and minerals back to the surface. In a very real sense, the hidden ocean is responsible for the dynamic nature of our planet. It's the reason why Earth is an active, changing world, rather than a dead, static one. In conclusion, the discovery of a massive ocean hidden beneath the Earth's surface is a game-changer for science. It challenges our theories about the origin of water, clarifies the workings of the mantle, and expands our search for life in the universe. It's a story of how a tiny diamond and the vibrations of the Earth revealed a secret world that is 3 times the size of all our surface oceans. It's a reminder that there is always more to the story, and that the Earth is much more than what we see on the surface. We live on a planet of mysteries, and every discovery we make only adds to the wonder of it all. So, the next time you look at the ocean, remember that there's another one, much larger and much deeper, right beneath your feet, quietly keeping our world alive.